Hello everyone. So in this media we are going to discuss about indicator diagrams basics. Okay, so you all are aware about indicator diagrams, but we are going to I have compiled in a nutshell in all together, which is easy for you. So we'll just browse it, we'll just go through it. So which is self-explanatory and understanding. Okay, I have taken extracts from different sources and different materials. So I'll not be naming it, so it will become very lengthy. So without any further ado, let's move on to our topic. So when we talk about indicators, so they have got two names, that is also known as monograph or pressograph. Consist of a small cylinder with a spring loaded piston moving up and down. Okay, cylinder space below the piston connected to the compression chamber by means of short length of tubing. Now, so indicator piston moves in accordance with the variation in the pressure prevailing in the engine cylinder. Now, movement is amplified and transferred by means of a link and lever mechanism to a stylus or pen. So you must have seen in your shipping career on ships this mechanism. So this is the basic construction and different parts that are there in the indicator. Now when we see, the stylus is brought in contact of indicator paper placed on cylindrical drum. Now this drum made to rotate a little less than 360 degree, alternatively to the right and left in accordance with main piston by means of a cord drive and a long coil spring. The direction of rotation is changed each time piston is at TDC or BDC due to core drive mechanism. Now this kind of design up to a press of 150 bar at a maximum of 400 rpm. The largest diagram length is 80 mm and maximum height is 50 mm. So now these couple of things are very important, and this is the largest diagram, that is 80 mm, and it is height is 50 mm, and it is 400 rpm, 150 bar, and this TDC and BDC aspect. So this we have to remember. Now why it is unsuitable for small and higher speed engine. Okay, so here there is a spelling error, so I bear forgiveness for that. So why, when engine speed high indicator, the piston, its spring and stylus will be unable to follow the pressure of main cylinder due to inertia. Okay, lag. Now high fluctuation of pressure is likely to create oscillation interfering with proper functioning of stylus. So we had seen the rpm, so to which all rpm it is valid. So why we are not moving it into the higher rpm? So because of inertia lag and high fluctuation of pressure is likely to create oscillation interfering with proper functioning of stylus. At high engine speed, high engine vibration is likely to transmit to the diagram. Okay, so this will vibration is likely to transmit to the diagram. So now the variation of the pressure is so large and rapid, a heavy spring does not respond quickly when the cylinder pressure is low. So see, imagine this is a mechanical system altogether. This is a mechanical aspect altogether. When you speak about today's, when we have this PMI, so I have made a separate video on PMI, you can watch that. So we PMI and all, the reason why we are running it for 1 hour, so that we want engine before taking the performance of the engine, the reason being is that we want the engine has to engine should come to the vibration has to be minimal, and there are other aspect also of fuel and oil as well. Okay, so we are going to the MCR speed, and then we are making it to run for a period of time. And why it is done? Vibration is one aspect there. So in PMI also we are taking into account. So this mechanical system, it will certainly affect the vibration will certainly affect your indicator diagram. When the clearance and volume is small, the additional volume of a piping and instrument leading to lower the compression ratio. Okay. Now, preparation for taking indicator diagram. What all preparation we do? Engine should be running for several hours to ensure normal working condition of the engine. Before mounting the indicator instrument on the indicator cock, the indicator cock should be blown through to remove impurities such as loose, soot, condensates and oil, etc. See, normal working condition, we are going to the maximum speed, and as per load condition and sea condition, we has to the ship has to be in loaded condition. These are prerequisite that we take into account. There should not be, the sea has to be calm, and you go to the speed, and sometime we may not go to the MCR speed altogether, but depending on chief engineer and captain's discretion, they come to a maximum RPM whatever they want. So now we are blowing through the indicator cock, okay, because there must be soot deposit over a period of time, because combustion is taking place inside, and then there will be some soot deposit will be there, so we want to remove it, so we just blow through. In any case we are doing it, even in case of soot blow also, even in case of PMI also, in case of this also we are doing. The moving parts like piston guides, rollers, etc. must be lubricated properly. So these parts must be lubricated properly. So the indicator paper, magnetic paper or carbon paper, must be mounted tightly on the indicator drum. Now the tip of the pin must be well rounded but not sharp, and its press should be minimum. So its press should be minimum, and tip has to be well mounted, and it has to be sharp. Now the cord drive for the indicator must be as simple and without any bends. The cord length should be adjusted such that when operating the drum does not touch the end stop. So it should not be able to touch your end stop. Care must be taken that the cord drive is not oblique. So the cord drive is not oblique. So this also has to be taken into account. Now what are the procedure that we follow? We did the pre-preparations, we saw what is the construction and why we are not using it in the higher speed engine. So now what all procedure for taking indicator diagram? When the cord length is satisfactory, the indicator cock is opened, the stylus will start moving up and down, the pen is then introduced to the paper. As soon as the diagram is drawn, the pen should be out of the paper. The indicator cock is then to be closed tightly. The pen is brought again to the paper to draw the atmospheric line. Okay. The indicator paper is then to be removed and preserved for calculations. Okay. So this is the procedure. Now, what are the parameters? So, see, every company based on their SMS, they have a certain procedure for taking the performance or indicator diagram. So they have you take out the printout of that blank form and you note down those parameters. So some of the key parameters which are common in everywhere, what we take into account, what we note down for our understanding for the calculation of this is a scavenge pressure, scavenge temperature, fuel indicator, engine room temperature, barometric pressure, turbocharger inlet and outlet temperature, engine RPM, fuel oil flow meter reading. So fuel and flow meter, this is also in the beginning and at the end. Okay. Now what is the purpose of indicator diagram? Now determination of the indicated engine output. So it determines the indicated engine output, determination of the combustion and compression pressure. So we can ascertain from here the combustion pressure and your compression pressure. Now the calculation of air temperature in the combustion chamber. Now we have calculation of air temperature in the combustion chamber, evaluation of combustion processes. So now we evaluate the combustion processes, power balancing. So what we are doing is we are doing power balancing. Now, what are the faults and failures that are there in indicator diagram that we are going to see? So till now, what we have seen is that what is the basic construction of indicator diagram, why it is not used for higher speed engine, why it is used for lower speed engines, and why what are the prerequisites that are supposed to be done, what are the steps that has to be followed to be done, and what are parameters that we note down and how it is ascertained and how it is calculated. Now what are the faults and failures that can occur? Now indicator diagrams failures can be classified in two categories. See, combustion process failure and instrument failure. Now we'll see what are the key parameters are there in combustion process failure. So when we speak about combustion process failure, it is early ignition and it is late ignition. Now low compression pressure, leaky or blockage fuel injector. Now when we speak about instrument air, drive cord vibration, cord length not properly adjusted, weak coil spring, sticky indicator instrument piston. So these are the key points that we are supposed to remember and we are supposed to express and we are supposed to tell to the surveyor when we are answering the question. Okay. Combustion process failures. So inferences, causes and faulty diagrams. So we are going to see in depth. So what are combustion processes failures? So how we can infer it and what are the causes of it? Okay, so when we speak about early ignition, inferences are there: combustion pressure too high, exhaust temperature lower than normal, heavy mechanical load on piston and bearings may lead to bearing failure. Now when we speak about possible causes, changing to higher cetane number oil than normal, fuel pump plunger set too high, incorrect adjustment of fuel cam on camshaft. Okay, now this incorrect adjustment of fuel cam on camshaft. Now, late ignition. When we speak about late ignition, what are the inferences? Low peak pressure, high exhaust temperature, high exhaust pressure. Possible causes: changing to lower cetane oil than normal, fuel pump plunger worn out in axial direction. Now we have incorrect adjustment of cam on the camshaft, leaky fuel pump, improper viscosity. Now low compression pressure, what are there? Inferences are compression, combustion and exhaust line all will be low. Now exhaust temperature will be higher. Now engine output will be lower. Now what are the possible causes that we can ascertain from here is that leaky piston rings. So piston rings will be leaky, leaky exhaust valve, scavenge air system fault. So scavenge air system will be fault, and then we have turbocharger failure. Now, faulty fuel injector. So inferences are that post combustion, low peak pressure, high exhaust temperature, low power output. Okay, what are the possible causes? Fuel valve not closed properly, resonance in fuel valve spring. So we have a resonance in fuel valve spring. Now when we speak about instrument failure, we are going to see in depth the inferences, causes and faulty diagrams. So possible causes are that engine vibration, resonance in indicator cord. So we will have all together a resonance which is occurring in the indicator cord. Now what are the possible causes? Elongation of cord. See, over a period of time it stretches because of its internal property of elasticity or whatever it is. So it stretches. So there will be a elongation altogether. Now instrument piston sticking. Now inferences, when we speak about increase in length of diagram, indicated mean pressure too high, possible causes inadequate lubrication, dust affecting piston clearance. Okay, so these are the possible causes that are there, and today what we have seen is about what is known as your indicator diagram basics. So we have seen what are the construction, what is the prerequisite, why it is not used on higher speed engine, how we take the indicator diagram, what are the parameters that we note down, and what are the faults inferences that are there, how your indicator diagram is getting affected with because of different parameters. So all these things we have seen in a nutshell. So I have tried to make it more concise and put up together here in points, in bullets, so that it becomes easy for you to assimilate. Okay, so that was the whole together idea. My idea in my videos are not to teach you, because you are knowing more than or far better than me, but my idea is to put up the stuff in one place, so that what the surveyor is expecting. So I'm doing a work on behalf of you for other areas, collecting material and then just put up in one place, so that it becomes easy for you to assimilate and grasp and represent it to the surveyor. Thank you so much.